Hi kids, I hope everybody is fine. So this video is for class 10 student and we will discuss mensuration from class 10. This is from L Aggarwal Exercise 17.1. Now before discussing the sums, let us see few terms which we should know. Solid. A figure which occupies a portion of space enclosed by plane or curved surface is known as a solid figure. For example, in case of a cuboid, the space is enclosed by plane surface. In case of a cylinder, the space is enclosed by curved surface, isn't it? That is a solid figure. Number 2, surface area. Surface area is the sum of the areas of the plane or curved surface. Sum of the areas of the plane or curved surface of a solid. That is known as surface area. Surface area or total surface area means the same thing. Remember, for example, if you talk about the cuboid, the room in which I am standing, this is a cuboid, okay? So total surface area is area of the four wall plus area of the top and area of the floor. That is the total surface area. In case of a cylinder, if you see, then surface area is area of the top and bottom, which is in the shape of a circle, and area of this curved part, which is known as curved surface area. The area of the curved part, remember, that is known as curved surface area. And curved surface area plus area of the top and the base is your total surface area. Clear? Now there is one more term, lateral surface area. What is lateral surface area? Lateral surface area? Very easy. The surface area excluding the area of the top and bottom of a solid. That is known as lateral surface area. For example, in this room, when I talk about, then the lateral surface area is nothing but area of the four walls. Not the top and the bottom is not included. Okay? That is your lateral surface area. Now, volume. The measurement of space enclosed in the solid. The measurement of space of enclosed in a solid, that is your volume. It is measured in centimeter cube, meter cube, liters, Solid has 3 dimensions, length, breadth and height. Okay. Surface area is measured in meter square, centimeter square. Okay. Now very important thing. Just look over here. Cross section. Look carefully. Cross section. Now, suppose I take a cylinder. Look over here. I take a cylinder. Okay. And this is the height. Okay. Perpendicular to a height, I make a cut like this. Perpendicular to the height. Then the surface exposed after making a cut, that is my cross section. Instead of cone, if you see, look over here carefully. If I make a cut perpendicular to the height, this is the height. Okay. Perpendicular to the height, then the surface exposed, that is the cross section. Okay. Now if you look at a cylinder, if I make a cut over here, then the surface exposed over here and here, the areas will be same now. They will be the same surface, but in case of a cone, if I make a cut over here at different point, then this surface and this surface are not same. The areas are not same. So this is a solid has a non-uniform cross section. But when you talk about a cylinder, it has uniform cross section. Because wherever you make a cut, the surface exposed is similar. At any point you make, where it is not similar. In case of a cuboid, a cube, they also have uniform cross section area. Because wherever you make a cut perpendicular to the length, breadth or height, you see that the area exposed is same. Am I clear? This will be useful when we find the volume. Now look at this. If a body has a uniform cross section area, if a body, remember, we are talking about solid which has uniform cross section area, then the volume of that body is given by area of cross section multiplied by the height, length or breadth, whatever. In case of a solid cylinder, look over here. If you make a cut like this, suppose this top and the bottom, we know a circular region. These are circular region, isn't it? So if you make a cut over here, you will get a circular region. Suppose the radius is r and the height is h. Then volume of the cylinder is equal to area of cross section. So this is a circular region, isn't it? And area of this circular region will be what? Pi r square into height, which means volume of a cylinder is pi r square h. Is it clear or not? Area of cross section into height. This we can only use for solids which have uniform cross section area. Okay, then comes your curved surface area. Curved surface area is perimeter of the cross section multiplied by height. Just look over here. So in this case, for the case of a cylinder I am talking about now, okay, I am discussing cylinder now. The perimeter of the cross section, which is in the form of a circle, will be 2 pi r into h, which means curved surface area of a cylinder is 2 pi r h. Okay, which means from here we can also get the total surface area of the cylinder. What? See carefully the diagram, the total surface area. The total surface area of the cylinder will be the curved surface area plus the area of the top and the area of the bottom. The top face is a circle, the bottom face is a circle again. So total surface area will be curved surface area 2 pi r h plus the area of the top pi r square, area of the bottom which is pi r square. So that's 2 pi r h plus 2 pi r square, isn't it? Take 2 pi r common. So when you take 2 pi r common, what is left? H plus r. So that is the total surface area for a cylinder, solid cylinder. I'm talking about a solid cylinder now. Okay. And what is a cylinder? How do you define a cylinder? You take a rectangular lamella, rectangular lamella, and you rotate this, along its height, one of its side, So the figure which you get, the solid figure, you'll get a 3D figure. That is a cylinder only, isn't it? So we got the volume of a cylinder, solid cylinder. This is for solid cylinder. Will do for hollow cylinder also. Pi r square h. The curved surface area of a solid cylinder is 2 pi r h, and the total surface area of a solid cylinder is 2 pi r bracket h plus r. We'll be needing this while doing the sums. Now let us see for a hollow cylinder. Now let us see a hollow cylinder. Now a hollow cylinder looks like this, isn't it? You must have seen a iron pipe, looks like this. Okay, you have two circular region. If you look carefully, suppose the radius of the inner one is small r and the outer is capital I, R, and the height is h. In between it's hollow cylinder. First of all, the thickness, thickness over here, look carefully, is capital R minus small r, isn't it? Yes or no? Number 2, the thickness of the cylinder is capital R minus small r. Area of cross section, if you look carefully, it's concentric circle, so area of cross section will be pi capital R square minus small r square. Done. Which means volume will be area of cross section into height. We just did. For a body having uniform cross section area, volume is given by area of cross section into height, which is pi capital R square minus small r square into h. Now when you talk about surface area, first of all, curved surface area. Now when you talk about curved surface area, which means this part, so we'll have an external curved surface area, because there are two faces, external and internal also will have a curved surface area. So external curved surface area is, just now we did, it was 2 pi RH, so in this case it will be 2 pi capital RH. Circumference, perimeter into height, so the perimeter of this is 2 pi capital R. For the internal it is 2 pi small r, which means internal curved surface area 2 pi small r h, which gives us total surface area. See, total surface area of a hollow cylinder, try to understand. External curved surface area plus internal curved surface area plus area of the top, which is pi capital R square minus small r square, plus area of the base, bottom, same, concentric circle. This is your total surface area. You can write 2 pi RH, capital RH plus 2 pi small rh, 2 pi capital RH plus 2 pi small rh plus 2 pi r square minus r square. Okay, this is your total surface area of a hollow cylinder. Am I clear? So these are the formulas which we need to remember before starting exercise 17.1. So now we look at the sums of 17.1. Now let us solve sums from exercise 17.1 L Aggarwal. Sum number 1. Find the total surface area of a solid cylinder of radius 5 cm and height 10 cm. Leave your answer in term of pi. Now we know TSA is 2 pi r h plus r for the solid cylinder. So just substitute the value. 2 into pi into r is 5 into 10 plus 5. That's 10 pi and this is 15. That's 150 pi centimeter square. Simple calculation. Just use the formula and put the values. Number 2. An electric geyser is cylindrical in shape, having diameter 35 centimeter and height 1.2 meter, which is in centimeter I'll do, okay? 120 centimeter. Okay? Neglecting the thickness of its wall, calculate its outer lateral surface area. Now, lateral surface area, curved surface area, same thing. And its capacity in liters, which means volume. Now, first of all, lateral surface area, LSA or curved surface area, is 2 pi RH. Just substitute the value. 2 pi is 22 by 7. R is how much? Diameter is 35. So radius will be 35 by 2 into H 120. Solve this. 2 cancels out, 7 ones are 7 fives are. Yes or no? That's 22. 5 0 times 0, 5 2 times 10, 5 ones are 5, 6. Yes or no? 2 6 are 12. 1 3 2 0 0 centimeter square. Simplify, you'll get the same answer. Now the volume. Look, they've asked capacity in liters. I'll first find in centimeter cube, and then I know how to change centimeter cube to liters. That won't be a problem. So volume in centimeter cube, pi r square h. That's the formula. Just substitute the value. That's 22 by 7 r square, which means 35 by 2 whole square into h. H is 120. So just solve it. 22 by 7 into 35 by 2 into 35 by 2 into 120. 7 1 time, 7 5 times, 2 1 time, 2 11 time, 2 1 time, 2 60 times. So this is 11 into 5 into 35 into 60 centimeter cube. Let me solve this, okay? 5 into 60 will be 300, isn't it? And 11 into 35, 35 into 11, just simplify. 35, this is 35, 385. So multiply by 385, 0, 0, 3 5 times 15, 24, 25, 3 3 is 9, 10, 11. So that's 115500 centimeter cube. Now, from centimeter cube to liters, how do you go? You divide by 1000, isn't it? From centimeter cube to liters, if you want to go, divide by 1000. So once you divide by 1000, it becomes 115.5 liters. And that's your answer. You just need to remember this conversion. Get the answer in centimeter cube and then change it to liters. Done? Chalo, we'll do number 3 now. Look at number 3. A school provides milk to the student daily in a cylindrical glass of diameter 7 centimeter. If the glass is filled with milk up to the height of 12 centimeter, find how many liters of milk is needed to serve 1600 students. This glass of milk is served to one student. So how much milk is served to 1600 students? That is what they have asked. Now look carefully. Volume of milk served to one student, pi r square h. That's the volume of this glass. Volume of the glass now, volume of the milk, which is in the shape of cylinder. So that will be 22 by 7. R square means diameter is 7. R will be 7 by 2 whole square. H is 12. Look carefully. 22 by 7 into 7 square is 49 by 4 into 12. 4 1 times, 4 3 times, 7 1 times, 7 7 times. That's 22 into 3 is 66 into 7. 7 6 times 42, 42, 46. Now 462 centimeter cube. That's the volume of the milk consumed by one student. So volume consumed by 1600 student is 462 into 1600 centimeter cube. This is the answer. But they've asked in liters, so what we'll do? We'll divide by 1000. This much liter. Solve it, we'll get the answer. Okay, so that's ultimately 462 multiplied by 16 divided by 10 liters. Very easy. Volume of volume of milk served to one student multiplied by 1600 gives you answer. And centimeter cube to liters you divide by 1000. Chalo, we'll do number 4 now. Now look at number 4. In the given figure, a rectangular tin foil of size 22 centimeter and 16 centimeter is wrapped around to form a cylinder of height 16 centimeter. Find the volume of the cylinder formed. Very easy. See, when it is rolled, then don't you think this 22 becomes the circumference of the circular region over here, which is 2 pi r, the circumference of this circular region, top or bottom, which is in the shape of a circle, okay, that will be equal to 22. And 2 into 22 by 7 into r is 22. So r is 22 into 7 by 2 into 22. Solve it. 22 cancels. This is 7 by 2 centimeter. That's the radius. And the height is 16. So what will be the volume? Pi r square h. Substitute the value. Pi r square. R is how much? 7 by 2 whole square. H is how much? 16. Substitute the value. 22 by 7. This is 49 by 4 into 16. For 1 time, for 4 times. 7 1 time, 7 7 times. That's 22 into 4 is 88 into 7. So 88 into 7 is 7 8 times 56. 7 8 times 56, 61. So 616 centimeter cube. That is the volume. Clear, very easy. You just need to remember that the length of this foil becomes the circumference when you talk about the cylinder. From there we get R. Once you get R, then volume is pi r square h. Now let us look at number 5. Now look at 5 part 1 what they have told. How many cubic meter of soil must be dug out to make a well 20 meter deep and 2 meter in diameter? You need to make a well. So you need to take out the soil, okay, and they have given the well is 20 meter deep. That becomes the height for the cylinder, and 2 meter in diameter, which means the radius is 1 meter. How many cubic meter of soil must be removed? Which means volume of this well, which is in the shape of a cylinder, pi r square h. Just substitute the value pi r square h. That's 22 by 7 into 20 meter cube. That's 440 by 7 meter cube, isn't it? Change it to mixed fraction. 6 times gives you 42. 7 2 times gives you 14. Then how much is left? 20, 14, 6. Look carefully. Yes or no? 62, 6 by 7 meter cube. That's the volume of the soil which must be removed. Now, there's one more part. Number 2. If the inner curved surface of the well in part 1 above is to be plastered at the rate of rupees 50 per meter square, the rate of plastering is rupees 50 per meter square. Find the cost of plastering. See, if the inner curved surface of the wall, inner curved surface, first of all, curved surface area is what? 2 pi RH. So the inner curved surface area will be 2 into 22 by 7 into 1 into 20. This much meter square. The rate is given. So what will be the total cost? Total cost will be the curved surface area, which is 2 into 22 by 7 into 1 into 20 into rupees 50. Yes or no? 52 times gives you 100 and 22 into 20 is 440 by 7. This much rupees. Okay, that's 44000 by 7. Change it to decimal. Okay, this much rupees you have to spend for the cost of plastering the inner surface. Okay, chalo. We'll do the next sum, number 6 now. Now look at number 6. A road roller is in the shape of a cylinder, has a diameter 0.7 meter and its width, this much, which is the height for the cylinder, and its width is 1.2 meter. Find the least number of revolution that the roller must make in order to level a playground of dimension 120 meter and 44 meter. How many revolution? Number of revolution they want. Okay, find the least number of revolution. Now look over here. We know number of revolution will be the area of the playground by the curved surface area of the roller. That is the logic over here, because this surface will be on the playground which will be rolling, so now area of the playground is what? Length into breadth, and CSA of roller, which means a cylinder, is 2 pi r. R is how much? 0.7 by 2. Yes or no? Into h. This is 1.2. Check out the calculation. 2 pi RH. 2 pi RH. And that is length into breadth of the playground. Yes or no? Wait. Now just do calculation. This 7, this is 0.1, 21, 2 times this, so this is 120 into 2 by 0.1 into 1.2. Yes or no? The point goes away, 10 comes. You solve on your own. 10 comes, 1 time, 10 times. That's 2000. So 2000 times it should, rotate completely, so that to cover the entire playground. Done? This is number 6. Now in this video, we'll keep it till here. In the next video, we'll see the rest of the sum. Till then, take care, be safe, and if you like the video, do subscribe and share with your friends.